Alright guys, thank you for watching this. This is a tutorial for the Unit 2 writing assessment that y'all are either haven't turned in or did not pass the first time. So the first question we are going to look at is like number 1 on your test. So we've got a parabola here. Part A says, what is the equation of the axis of symmetry? So I'm going to draw a red dotted line where our axis of symmetry is. So what that means is that this parabola is symmetrical on both sides. So as you can see, we have a point here, and it would pair exactly with a point over here. Same thing here. As you can see, if this is our axis of symmetry, it's 2 spaces over. Same with this point. So we're going to write that as an equation. It's always written as an equation. So we check our x value, which is -1. So that equation is going to be x equals -1. For part B, it asks you for the coordinates. So you cannot just give a number. It asks for the coordinates of the vertex. So remember, the vertex is the point where it changes directions. I'm going to highlight the vertex right here. It's that green point at the top. So coordinates are written as x value, then y. So to get to that point, we go from the origin, right here at 0, 0, we go left 1, so that would be -1, and we go up 1, 2, 3, 4. So it would be at the point -1, 4. For part C, the coordinates of the x-intercept. So that's where it's crossing the x-axis, which is the axis that runs left and right. I'm going to highlight it in blue. That's our x-axis. So where does it cross? It's going to cross right here and right here. And again, it's asking you for the coordinates, so we have to list them as an ordered pair. So this would be -3, 0. And this point would be 1, 0. Lastly, it asks for the coordinates of the y-intercept, or where it crosses the y-axis. The y-axis goes up and down, so we're talking about that point. So x is always going to be 0 when it's a y-intercept, and we're going to have the point 0, 3. Okay, this is going to help you with number 2 of your graphing, of your Unit 2 writing assignment. So the first thing is to describe the transformation. So this is our original parent function, x squared. What we're going to do is we're going to talk about, for part A, the different pieces that are different. So for instance, we have a 3 in front of x. So that means that this is, remember, if we have a number in front of x that's greater than 1, it's going to be called a vertical stretch. So vertical stretch by 3. We also, inside the parentheses, have, this should be like this, sorry. That makes a little more sense for you. Since this is -3 inside the parentheses, we're going to do the opposite of what we think. So it shifts to the right 3, and then at the very end, it goes -2. So that would be down 2. So all you need to do for part A is just tell me what's happening that's different. For part B, we're actually going to graph these. So I'm going to let my parent function be in red. So it's always going to start at 0, 0. And it's going to have the points 1, 1, and then 2, 4. And I'm going to draw a line through. So another way that you can do this is to just pull up your graphing calculator. I'm going to load mine up right now. Oh, where'd it go? Okay. So I'm just going to go to y equals and clear that out. I'm going to type in this new equation. So 3 times x minus, whoops, that should be a 3 squared, and then -2. And I'm going to go ahead and graph that. So it should show me a new point Okay, and I'm actually going to go to second table, and that's going to tell me where I should put some of these points. So we have the point 2, 1. Oh, let me do it in a different color. I'll do it in blue. So we have the point 2, 1. 3, -2. Sorry, this calculator keeps going away. And then 4, 1. So, as you can see, it's a little bit skinnier. It shifted to the right 3 and then down 2. All right, and the last thing that we're going to do on this is a quadratic regression. So you're going to use your calculator to hit the stat button, and then you're going to edit your list. So what we have on the left side should be our L1, and that's going to be this top row of numbers. So what I will do is just type them all in. Okay, and then I'm going to go back over to my L2 and type in the values that are for soil density. So I have 1040. Uh-oh, somehow I got a little bit goofed here. Not all my numbers were going in. Okay, let's try this again. 1068. Oh, why is it not reading that? 068. It's going a little fast. 1, 1, 2, 2. Okay, so I've got all my data entered. A is asking me to write the quadratic regression equation that models. So I'm going to go back to the stat button. I'm going to arrow over to calculate, and then I want number 5, quadratic regression. So I'm going to come down and tell it to go ahead and calculate. So as you can see, it's going to give you, at the top it tells you the equation, and then it tells you what A, B, and C are. So there we go. A is 0.2, we'll call it 0.25. So I'm going to come down here and write y equals, this is for part A, 0.25x squared. B is negative 3.35, so then that's going to be minus 3.35x. And C is plus 1199.65, so plus 1199.65. So that's all I have to do for part A. That's my equation. For part B, it says use the equation to estimate the soil density of a sample at the depth of 20. So I'm just going to plug in, x is going to be 20. So I would get 0.25 times 20 squared minus 3.35 times 20 plus 1199.65. Now, you don't have to type all this into your calculator. The easiest thing to do is to go back to your y equals, and we're going to type in our equation that we wrote in part A. So 0.25x squared minus 3.35x plus 1199.65. And then what I'm going to do is I'm going to hit the second button and then graph, because that will give me a table. So all I'm going to do then for my table is scroll down to the number 20. Okay, there it is. At 20, my y value, or my depth, So y of 20 would be 1,232.7 feet. 1,232.7 meters. And that's it.